Bananas. Okay. We are given two functions. One function represents the rate at which bananas are removed from the display table, and the other, the rate at which they are placed onto the display table. We'll note a couple of things. One, 50 pounds of bananas to start with. Number two, time interval for bananas being removed is 0 to 12. Number three, time interval for bananas being placed on doesn't start till 3. And so all of that is important stuff. All right, how many pounds of bananas are removed from the display during the first 2 hours? That should be easy. It should just be the integral from 0 to 2 of the function that represents the rate at which the bananas are being removed. So what's the integral from 0 to 2 of f of t dt? What?
20.
Agree with that? 20.0510? 20.051? Yeah. Pounds of bananas. And I was going to have the scoring guidelines up, and then I had to take attendance. Oh no, I didn't resubmit the attendance after fixing So I think they gave you 2 points for that one, actually. You gotta find the banana problem, though. Add it up. Where's the banana problem? That's not the banana problem. Oh, I had the banana problem up earlier, and I didn't close it. Oh, well, yeah, it was 2 points. One for the integral and one for the answer. Yeah? Good with that? Everybody good with that? Then f prime of 7. So f prime of 7, you should be able to find the value of that really easily because you don't actually need to take the derivative by hand. Not that it's that bad to take that derivative, it just requires the product rule and the chain rule. But your calculator will evaluate that derivative at 7 for you, and I believe it came out to be negative 8.120. Does that sound right? And I believe on the scoring guideline it actually said negative 8.120 or negative 8.199. No, 119. Then they would have given you either one. Sometimes they give you 1/1000 of a lira. All right. And then we needed to explain what that meant in the context of the problem, and we needed to use correct units. So this is the rate of change, right? The derivative of something. That's a rate of change of f. So it's the rate of change of the rate at which the bananas are moving off of the table, being removed from the table. So we would say that the rate at which bananas are removed is decreasing at 8.120 pounds per hour per hour. Pounds per hour squared or pounds per hour, however you want to write it. Since we know that f of t is pounds per hour and t is in hours, so when we take that derivative, it gives us per hour. Everybody good with that? No issues there? Everyone feels okay about that? We're all good? Everybody's good? 2 points for that. One for the value and one for the explanation. Okay. Part C says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? So what we need is the derivative of an equation that represents number of pounds on the table. Right, so let's write an equation for the number of pounds on the table at any given time after t equals 3. So the number of pounds on the table ought to be the initial amount that was on the table. True? That was 50 pounds. Plus the amount that was put onto the table. How much was put onto the table? The integral from 3, when they started putting them on the table, to t of the function g. And then they subtracted some off of the table, right? People remove stuff, so we're going to subtract the integral from 0 to t of f. That function represents number of pounds on the table. Everybody agree with that? We want to know, is this thing increasing or decreasing at t equals 5? So we want to take the derivative of this. The derivative of this, well, the derivative of 50 is 0. So I'm going to say derivative here. The derivative of the integral from 3 to t of g is just g of t. And the derivative of the integral from 0 to t of f is just f of t. So we want to know, is g of t minus f of t at t equals 5 positive, or is it negative? And what's the value that you got? Negative 2 point what? Negative 2.263, which is less than 0. Therefore, the number of bananas on the table is decreasing at t equals 5. They gave you 1 point for evaluating this, or for setting up that it needs to be g of 5 and f of 5, and 1 point for your explanation. Correct. You didn't need to write this. Usually in these rate problems, though, eventually they're going to be like, how much of it was there at this point, which is what D is. So you're going to need this equation eventually. But yeah, this was not, that top line was not associated with any points in part C. But I only write it here in part C just because I think it's good for us to get used to understanding what the levels of relationship between the rate and the actual amount. Good job, Patrick. Good question, Patrick. You're welcome. Okay. Let's see here. What was part D asking? The amount at 8? Yeah? Okay. 8, right? Yeah, okay. So we're just going to go back to that original equation that we just had, 50 plus the integral from 3 to 8 of g minus the integral from 0 to 8 of f. And whatever you get when you plug all of that crap into your calculator is your answer, which came out to be 20 something, I think, if I remember. 23.347 pounds of bananas. And they gave you 1 point for the setup and 1 point for the answer. That only makes 8 points, huh? That I've said so far. I must have forgotten where one of those points was. Now I do need the scoring guidelines. Now 2 points for the integrals. There we go. And 1 point for the answer. Everybody go with that? Wonderful. All right. Are we feeling okay about rate FRQs? We're going to do a bunch more rate FRQs eventually down the road after this May 4th test. But like I said, I just want to introduce as many different types as I can before May 4th for everybody that's on the May 4th. So we're going to have a quiz specifically on rate FRQs. We'll practice 5 or 6 more of them before that happens in a week or 2. All right. Now we have the graph problems that nobody was a big fan of, apparently. You guys don't like the graphs? What? 2A? You don't like the part A of the next one? But part A of this one was okay? Such a quitter. It took you 10 minutes to quit? You just wasted 10 minutes of your life? 10 minutes on the AP test staring at it, doing nothing. You should have, if you looked at it and said, I don't know how to do that, you should have moved to part B immediately. That's poor test taking. Very disappointing. Y'all are huge disappointments. Well, I mean, height-wise, maybe not so much, but all right. So let's see here. How you guys all doing there at home in the Zoom? You guys good? You enjoying
Yeah.
me?
Yes.
You're
Yep.
enjoying me just saying random things that you can't hear the other part of, probably? All right, cool.
We can barely hear it.
You can barely hear what they're saying. That's good.
There's like a muffled like mumbling coming from there where you get a word every now and then.
And then me like making fun of people. Yeah, that's good. Fun.
Tom is short.
Yeah,
That's
you
all
got it. You got it, Josh. That's good. You got it figured out. All right. Part A. -6 to 5, the integral from -6 to 5 of f of x is 7, right? We want to find the value of the integral from -6 to -2 of f. So since we have only the graph from -2 to 5, what we need to do is we need to set this up using some of those rules for integrals. So we know that the integral from -6 to 5 of f should be the integral from -6 to -2 of f plus the integral from -2 to 5 of f. Everybody agree with that? And if I take -6 to -2 and -2 to 5 of the same curve, that should be -6 to 5 of that curve. Everybody agree there?
Yes.
Wonderful. Okay. So we know that the integral from -6 to 5 of f is 7, so we'll put that in. We are looking for the integral from -6 to -2. Don't know why I wrote it like that. And we need to add to it this thing from -2 to 5. So we need to find the integral from -2 to 5 of that. Everybody good there? Okay. So we will do this in a couple of parts here. First off, from -2 to -1, it's just a triangle. That should be an easy section to figure out. It's a triangle that's above the x-axis. Yeah. So that should be 1/2 of the base times the height. Just gives us a half. Everybody agree with that? Second piece should be this triangle below the x-axis, which is 1/2 of the base, which in this case is 1.5 or 3/2, and the height, which is 1. And since that's below the x-axis, we've got to make it negative. And that area, or the integral itself, comes out to be negative. So this is -3/4. Everybody good with that? Yeah, great. All right. From 1/2 to 2, we've got another triangle, right? That one is above the x-axis, so that should just be 1/2 the base, which is 3/2, times the height, which is 3. That should be a positive 9/4, being above the x-axis. And then lastly, we need to figure out this area that is between the outside of that quarter circle and the x-axis. And so we have to take the entire section of this square from 2 to 5, which is 9, and subtract this stuff in the quarter circle part. And the area of a quarter circle is 1/4 pi times the radius, in this case, 2 squared. So that ends up giving us what? 9 minus, what is it? 1. What? Oh, sorry, the radius is 3, not 2. I know how to count. 9 minus 9 pi over 4. Everybody good with that? So if we combine together all of those things, 1/2 minus 3/4, that's -1/4. Add 9/4 to that, that's 8/4. 8/4 is 2. So then we have 2 and 9 minus 9 pi over 4. So that'd be 11 minus 9 pi over 4. Everybody good with that? And we want to find -6 to -2, so we'll do 7 minus 11 minus 9 pi over 4, which will give us a positive 9 pi over 4. And then 7 minus 11 is -4. That's fairly complicated. Okay. It wasn't that complicated, but fairly time consuming. You okay, Tom? No, anything's complicated if you don't know how to do it. I don't know. Everybody get with part A now? We're all good?
Can you re-explain how you got minus 1/4 pi 3 squared?
Sure. So I want to have another color to use here. But the toolbar showed up. Okay. I took this square,
Mhm.
which is 9.
Yeah.
And I subtracted. Let's use a different color for that. I subtracted this quarter circle from it, the area of just a quarter circle, to give me just the piece between.
Oh, I see. Okay, yeah.
And the quarter circle is a quarter of pi r squared.
Yeah, I didn't realize the quarter circle part. Yeah. Thank you.
No problem. Everybody good with that now? Okay. Cool. Let's see. How many points? I don't even know. I have no clue how many points that was worth. Let's see here. Gotta try and find. I had these up earlier, but now I don't know what happened to them all. There it is. All right, those were 3 points. 1 point if you set this up correctly. 1 point for correctly getting this value, and 1 point for getting the final value. So 3 points per part. Everybody good there? Part B, let's just get a new page here. Part B says we're going to integrate 2f prime of x plus 4 dx. Is it plus 4? Yeah.
Yes.
3 to 5? Cool. So what's the integral of 2f prime of x?
2 times f of x.
2 times f of x. What's the integral of 4? 4x. They gave you 1 point if you got that. Then they gave you 1 more point if you could do arithmetic correctly. So we'll plug in the stuff here. 2f of 5 plus 20 minus 2f of 3 plus 12. Everybody good there? What's f of 5? Well, we go back and we look. F of 5 is 0. So we have 0 plus 20 minus 2f of 3. Well, f of 3, what is that? Oh, look at that. They gave us the value. 3 minus root 5. So this is 2 times 3 minus root 5. And we also need to subtract the 12. So we got 20 minus 6 minus 12 is 2. And we got minus a negative root 5 is a plus root. And they gave you 1 point for that. So 1 point for correctly integrating, 1 point for getting the final answer correct. Everybody good there?
I got 2 plus 2 root 5.
Oh, sorry, I forgot. I didn't distribute my 2, did I? Yeah, 2 plus 2. Sorry. Don't forget to distribute the 2. Kind of important. Good? Zoom people, are you all good? Zoom good?
Actually,
Uh-oh.
so
Oh no! I'm used to being able to just say good Zoom. Okay, what's the question?
so like I broke like the integral up into 2. So instead of like having the entire thing in brackets with 5 to 3, I have it like 2 brackets. Is that fine?
That's fine.
Okay.
Totally fine, no problem. Zoom good?
Yes.
Yes.
Good Zoom. All right. Perfect. Part C. Find the absolute maximum of G on the interval from -2 to 5. Now, I made a big deal about this last night sometime in the review session. If they ask you for an absolute max on a closed interval, what do you need to remember to check? The endpoints. Endpoints. Check the endpoints. So we are interested in both -2 and 5, but also any critical values that we might have for G. So what are the critical values of G? Well, G prime should just be what? What's the derivative of this? It's
F.
just f. Yeah, it's just f, right? G prime is just f. G prime is f of x. So when does this equal 0? When is f 0 or when is f undefined? 0 here at -1, and again at 1/2. Two critical values, -1 and +1/2. We could eliminate one of those right off the bat, because if f is the derivative of g, here f is positive, so so g is increasing, and then here f starts decreasing. So we could have a max at -1, but from -1 to 1/2, g is decreasing, and then it starts increasing. So at x equals -1, this is a local max, potentially an absolute max. And at 1/2, it's a local min. So you don't have to check the value at 1/2 because you know it's a local minimum. And if it's a local minimum, you're definitely not going to have that be an absolute maximum. Does that make sense? But you could check it if you want. If you didn't do that, it's okay. So really, we have -2, 5, and -1 that we really need to check. So we need to figure out what is g of -5. Well, g of not -5, g of -2, right? That was the endpoint, -2, which should be the integral from -2 to -2 of f. Well, what is that? 0. G of -1 should be the integral from -2 to -1 of f. Well, conveniently, we did that. We found the integral from -2 to -1, right? It was just this triangle. It was 1/2. We found that early. If we wanted to, we could go back and, figure out the value at 1/2. That'd be 1/2, and then the -3/4 would be -1/4. But we would see that that was clearly less than 0 and less than 1/2. And then our value at g of 5, which we also already found, right? Didn't we find the integral from -2 to 5 of f of t dt earlier? The integral from -2 to 5 of f was this, right? 11 minus 9 pi over 4. You all agree with that? Which one of these is the biggest? Not that one. Not that one. This one. Absolute max is 11 minus 9 pi over 4. Okay, that was worth 3 points. 1 point for the answer, 1 point for finding -1 as a potential value and trying to figure out what it was at -1, and 1 point for recognizing that g prime is f. So you need to write that. Write that g prime is f if you didn't write that. Always write out the relationships between the functions and their derivatives in the free response if it's something that's pertinent to the question you're working on. Does that make sense, everyone? Zoom, good.
Wait,
For-
how did, sorry. Wait, how did we know that the -1 was a maximum as opposed to a minimum?
So remember that f is the derivative of g. So when we're looking at whether g is increasing or decreasing, we look at its derivative, we look at f. So f was greater than 0 from -2 to -1, telling us that it was increasing. Then f, which is g prime, was negative in between, which told us it was decreasing. So that told us we had a local max at -1. Then the derivative of g, f, went back to being positive, which meant that the function g started increasing again at 1/2, which is why we knew it was a max at -1 and a min at 1/2.
Okay, got it. Thank you.
Yep.
So since we yeah, I have a quick question. Since we determined that 1/2 is a critical value, would we have to like somehow show that like we don't need to check it because it is like decreasing from -1 to 1/2?
I would recommend either saying that it's a min or just checking it and putting the value there. In the scoring guidelines, they do not indicate that you need to have shown a value for 1/2, and they did not give a point for showing all the critical values. Their points specifically say G prime equals F, 1 point, identifies X equals -1 as a candidate, 1 point, and then answer with justification, 1 point. Now, their justification that they use shows a chart with -2, 0, -1, 1/2, 1/2, -1/4, and then 5, 11, -9, 5/4. So they showed the value at 1/2. So you either need to show the value at 1/2 or you need to indicate why you're not looking for that value because it's a local number. Does that make sense? Does that answer your question?
Yes, thank you.
No problem. All right. Part D asks us for the limit as x approaches 1 of 10 to the x minus 3f prime over f of x minus inverse tangent x. Is that right? All right. Now, oftentimes on the AP test in the free response question, maybe not often, but every once in a while, they will give you a limit question, just some random limit question that doesn't really seem like it's really all that related to what you've been doing, right? So this doesn't seem that it's really all that related. They just want to see if you can find a limit. A lot of the time, those limits will turn out to be indeterminate because they want you to use L'Hopital's rule. Okay? But what should you do first? Plug in the 1, plug in whatever number they give you, and see if it's actually indeterminate. Because if it's not, if they give you a number, if you get a number, then you're done. You got a number. And in this case, this one is not indeterminate. And so I think this is a pretty easy problem. I think they're banking on people missing this by going, oh, it's probably indeterminate, because most of the time they give indeterminate ones and they don't plug in the 1. They want to see that the first thing you need to do is plug in that value, which is why I made a big deal about it in the review session, and I make a big deal about it all the time. I just make people like repeat over and over again. What do you do with the limit? You plug in the value, plug it in, right? So this becomes 10 to the first minus 3f prime of 1, which we'll find in a second, over f of 1, which we'll find in a second, minus the inverse tangent of 1, which is pi over 4. So what is f prime of 1? Well, that's the slope of f at 1. So at 1, on this linear piece right here, what is the slope at 1? Well, it goes up 2 over 1, up 2 over 1. That slope is 2, right? The slope of f at 1 is 2, so we have 10 minus 6. And then what is f of 1? Looking back at the graph, f of 1 is 1. We have 1 minus pi. So your final answer should have been 4 over 1 minus pi over 4. They gave you 1 point for that. Yeah. Four over 1 minus pi over 4. This. Yep. I mean, if you want to get a common denominator of 4 and write 16 over 1 minus pi, knock yourself out. But you don't need to. Yeah. So I don't know if you guys can hear that question from Tom. Tom asked if would you ever have to find f prime of 1 for something that's not linear? Potentially, but they would have to give you the function's value. So like if you look at the next one that we did, right, they gave us a parabola. So they might ask you, they might ask you about f prime of 5 or g prime of 5 since this is g. But since you know the equation of that parabola, they gave it to you, you should get 5. So potential. Yeah. Any other questions there on the last one, on that limit, or anything else from that problem at all? No? All right. Let's look at this one then. If f of 1 is 3, what's the value of f of -5? So if f of 1 is 3, right, and f and g are related, that g is the derivative of f, g is f prime, right? When we integrate that to find what f is, this is an indefinite integral, right? So we're saying that f is the integral of g plus some constant. We are given an initial condition that f of 1 is 3. So if I put a 1 as my lower limit, we should be able to figure out this constant. And we did this way back when we were doing the fundamental theorem of calculus. And we said, make the lower limit this number that you're plugging in, and then that will allow you to find the constant. The constant will be 3, because if I do the integral from 1 to 1 of g of t, that's 0. And then I have to add a constant to it, and the value I'm supposed to get is 3. So we should know that f of x is equal to the integral from 1 to x of g of t dt plus 3. Does that make sense to everybody? This is fairly common that they will give you some sort of initial condition here and have you set up this integral using the first part of the fundamental theorem of calculus. Fairly common. So make sure you're good with that. Is everybody okay with that setup? You need to write what? They are going to assume you have a reasonable level of competence, that you don't need to write out every little reason why you're doing things. If it says explain your reasoning, then yes. But if it doesn't say that, just the math work is totally good. Yeah. All right, everybody okay with that setup? Yeah. So then it asks, what's f of negative 5? Well, f of negative 5 ought to be the integral from 1 to negative 5 of g plus 3. And if we're going to integrate from 1 to negative 5, that means we're going right to left. We don't want to do that. We want to go left, right. So how do we switch those limits of integration? Just change them, yep, and put a negative out in front. So negative 5 to 1 g of t dt plus 3. And so now all we have to do is figure out what the integral from negative 5 to 1 of g of t is. Well, luckily, we have a square. The first piece is 9, and it's below the x-axis, which makes it a negative 9. Then we have this little triangle here, which is also below the x-axis, so we'll say minus 1/2 the base times the height. Then we have a piece that's flat across the x-axis. That's going to be nothing, right? That'll be 0. Then we've got this other little triangular piece above, which will be a positive 1/2 of 1 for the base and 2 for the height. Everybody good with that? So that's the integral from negative 5 to 1. So that's negative 9 minus 3/2 plus 1. So what is that? Negative 19/2. All right, did I do that? Did I do that arithmetic right? I hope. And then we'll note that we had a negative out in front of all of that. And we will note that there's a plus 3. So it's the opposite of that integral, plus 3. So that's 19/2 plus 3, 19/2 plus 6/2, or 25/2. Good or no? Question? Right, I put the 1 as the lower limit initially because that's the value that I can evaluate, that I already know the value of that. Right, and so I can, I'll write this on another page. I can say, over my letters here. f of x it can be the integral from any constant, we'll call it constant 1 to x of g of t dt plus some other constant. It can be any constant down here because all that needs to be true is that when we take the derivative of f, right, f prime of x needs to be g of x. So that's fine for any constant, true? And for any constant over here as well, right? That's the condition that we needed. We needed that f prime equal g. And so we've done that, but we know that f of 1 equals 3, so we strategically choose constant 1 to be 1. That way, I know that f of 1 is the integral from 1 to 1 of g of t dt plus some other constant. And f of 1 is 3. And so this, the integral from 1 to 1 of any function is 0. So we get 0 plus that second constant. Does that make sense? Everybody good with that? Zoom, good. For this particular one. Yep. And if you look at like the next problem, which I'm going to have you guys do in a minute, they give you an initial condition of f of -2 is 7. So this one, your lower limit for your integral is going to have to be -2, right? And so that's a common thing that they do. If you look at the next one, now that one they didn't give you one. That one's different. This one different. Yeah, this one's different. Yeah, some of them are different. Some of them have these. That one they didn't. So sometimes they give you something, sometimes they don't. But that next one. Everybody good? Zoom good?
Yes.
Wonderful. All right. Part B, evaluate the integral from 1 to 6 of g of x. Okay. Well, that's going to be this square plus the area underneath the parabola. Yeah? What's the square? 4? So that's going to be 4 plus the integral from 3 to 6 of 2 times x minus 4 squared dx. That's the equation of the parabola. So I'm going to write this on a new page just so we have a little more room. Yeah, 4 plus the integral from 3 to 6. Is it 2 times x minus 4 squared? Is that right? Yeah. Okay. How do we integrate 2 times x minus 4 squared? Has to be a u sub, u equals x minus 2. So du is dx. So really this just becomes an integral of 2u squared. What's the integral of 2u squared? 2/3 u cubed. And so we'll just throw back the u in as an x minus 2. We get 4 plus 2/3 of x. Sorry, x minus 4. Sorry, I don't know why I said x minus 2. X minus 4. Yeah, x minus 4 cubed. I realized that right as I started writing. Everybody good with that? Wonderful. Then we evaluate. 4 plus 2/3 of 6 minus 4 is 2. 2 cubed is 8. So 2/3 of 8. And then minus, plug in 3. That's -1 cubed, which is -1. So minus -2/3. So we have 16/3 plus 2/3. That's 8/3. 8/3 is 6. Right? 18/3. I don't know. I'm having trouble saying words apparently. 16/3 plus 2/3 is 18/3. 18/3 is 6. 6 plus 4 is 10. Everybody good there? Good. Great. You all right there, Tom? All right, fair enough. All right, part C. We want to know if on the interval -5 to 6, is there any places where f is increasing and concave up? So we want f to be increasing. We want f to be concave up. What does that tell you? What does f increasing tell you about the derivative of f? Tells you that f prime is positive. What does f being concave up tell you? F double prime is positive. All right, we look back here, we don't have a graph of f, we have a graph of g. So really, we're going to want to deal with g. Let me clear this off so we can see this a little bit better. Okay. We know that f prime is equal to g. True? Which tells us that f double prime should be equal to g prime. So really, when we talk about f prime being positive, that means g is positive. And when we talk about f double prime being positive, that means that g prime is positive. Okay? So we have a graph of g. It should be pretty easy to tell when g is positive. We look at the graph. When is g positive? From 0 to 6, except at 4, but we'll just, effectively from 0 to 6. Yeah? What about concave up? When is g prime greater than 0? Well, that'd be when the slope of g is positive, right? That's what g prime is. It's the slope of g. So when is the slope of g positive? Is the slope of g positive here? No. What about here? Yes. So from -2 to -1. Not positive here, but positive from 0 to 1. Not positive from 1 to 3, because that's 0. Not positive from 3 to 4, those are negative slopes. But from 4 to 6, the slopes are positive. So we have 3 intervals when that's true. This one's 0 to 6. -2 to -1 doesn't overlap 0 to 6. 0 to 1 does, so does 4 to 6. So our final answer should be 0 to 1 and 4 to 6. Specifically in parentheses for 2 reasons. One, because it's dealing with concavity, and it's dealing with increasing, decreasing, and concavity. So the smaller of those is what you use. So we're going to use the concavity, which is parentheses. But also, it specifically says on what open intervals. So. Any questions on that? Everyone's good? All right. Part D, find the x coordinate of each point of inflection for f. So if f has a point of inflection, that means that f double prime changes signs, right? That means that we have a change in concavity. Well, what was f double prime? F double prime was g prime. So we want to know, when does g prime change sign? So when does the slope of g go from positive to negative or from negative to positive? Good? We look back at the graph. The slope of g here is 0. Then it goes to positive slope. Is that a change from positive to negative or negative to positive? Nope, because it's 0. 0 to positive is not a change in concavity. Positive to 0, is that a change in concavity? No. 0 to positive, is that a change in concavity? Still no. Positive to 0? Still no. 0 to negative? Still no. Negative to positive? Yes. So one time at x equals 4. And that's the end of that problem. Good or no? I believe it says give a reason. Is that what it says? Yeah. So there's no work that you need to show. You just need to say at x equals 4, then you would say f double prime goes from negative to positive, or f double prime changes signs, or something like that. Everybody good there? Any questions on that? Everyone's good? All right.